So far, we've stuck to the good parts of data design town. Now, let's see what they're selling on the wrong side of the tracks. Welcome to this video on database normalization. My name is Kevin Fiesel, and I'm the proprietor of Catalxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the final video of this series, we are going to look at several side topics around normalization. But to do that, we're going to need to head into the classroom and see what the professor has to say this time. Hello, class. This is the final time that I'll see all of you. Well, except for the final exam. And next semester for most of you who've been playing on your phones rather than taking notes. But today is not about that. Instead, today is a potpourri day where we're going to hit on several topics. The first topic is data warehousing. Relational database theorists like C.J. Date tend not to like Ralph Kimball's data warehousing model very much. And let's face it, for an all-purpose relational model, the star schema is terrible. But that's also an unfair assessment, because the Kimball fact-dimensional model isn't intended for transactional databases. It's a model specifically for data warehousing. And a Kimball data model is kind of like a mogwai. Don't get it wet. Don't feed it after midnight. You break the rules, you get the gremlins. The specific rules for a Kimball model to prevent database gremlins is as follows. First, we have one and only one process to write data into the database. The reason we need to have exactly one process to write data is that our dimensions are wide, and we can have a lot of repetition across dimensions. So we are going to need the single process to make sure that when we update data, we update it everywhere. We can't have some people writing data using the official process, some people writing ad hoc SQL queries, and other people using some business tool to write to the warehouse, as that's a recipe for disaster when you miss some of the critical business rules and transformations. Second, the model must be a proper model of business processes and understanding. The whole point of a Kimball fact dimension model is that this represents data in a way that business users can easily understand and work in tools like Excel. Within the model, facts represent measurements of things. With facts, we store dates and numbers, answering questions like when and how many. Dimensions, meanwhile, represent additional information about those facts. They help explain the who, what, where, why, and how. And finally, we use the appropriate slowly changing dimension type for each dimension. If you follow all of these rules, then your data warehouse can be successful. If you don't follow these rules, well, maybe it's best not to keep a data warehouse as a pet in that case. The next topic is overnormalization. Overnormalization does not exist. It is not a thing, not real, fake news. What people tend to see as overnormalization is really one of two things. The first is trying to remove legitimate business flexibility. For example, suppose we sell albums at a store. Each album has a sales price. When a person checks out, the salesperson scans each album and includes them as order lines. With this configuration, we can calculate the subtotal by multiplying price times quantity to get that order subtotal. But then somebody comes in and says, "Hey, I just got done listening to America's Greatest Professor." That's me, by the way. And I know you should remove price from that order line relvar because it's duplicate information. But is it really duplicate information? The answer is no, and you needed to listen to me better. The price on the album is the suggested retail price. But on each order, we might have a different price. That price could come because the album is currently on sale, or management has offered a discount to clear out that album. Also, the price on the order line is a point-in-time fact. It is the amount that we actually charged on that order. So, regardless of what price changes happen in the future, that's what we actually charged the person. So, even though the name of the attribute is the same, it doesn't mean the purpose is the same. Removing it also removes legitimate business flexibility. So, that's not overnormalization. That's just poor understanding of the business. The other thing we tend to see when people decry overnormalization is lossy decomposition and phantom rows. Let's go back to our fifth normal form example. Here we have the combination of store, genre, and artist. Remember that we spent a lot of time talking about symmetric constraints, and that the only way we can break this into 3 relvars is if there is a symmetric constraint. If we do not have a symmetric constraint, but do break this into 3 relvars, we can end up adding a new row and reconstituting these relvars in a way which should not apply, leaving the music store forced to sell a prog rock album because the data model demands it, regardless of whether they actually put it on the sales floor. This kind of phantom row problem, again, is not a failure of normalization. It's a failure to understand the data model. Now let's talk about the first thing many of you students probably had in mind, given the title of this lecture. Let's talk about denormalization. Normalization has very specific rules that we can define in formal logic. You can tell which normal form you're at, as well as what you need to do to get to the next level. With denormalization, however, we have none of this. That leads to several questions. First, denormalize to what extent? When do we know we're done denormalizing? Second, which method or methods should I use to denormalize relvars? What formal guidance can you offer? What formal logic can you provide to guarantee success? Third, is my data model sufficiently denormalized? Am I done yet, or do I need to go a bit further? Finally, how do I know that my data model has been denormalized correctly? What rules can I follow to ensure that I don't denormalize something incorrectly? The short answer here is denormalization doesn't have any formal rules, isn't based in formal logic, and the correct action is not clear. But let's not beat up entirely on denormalization, because it's not always the wrong answer. Denormalization to increase data redundancy can be okay when it is absolutely necessary. For example, data warehouses are an exercise in denormalization, and we've already established the fact that they're fine if we follow the rules around them. But denormalization can add invalid design ideas back in, the kind of stuff that we removed by going to Boyce-Codd normal form and fifth normal form. If you do decide to denormalize any given relvar, be sure that you don't introduce things like update anomalies right back in as a result of your action. And that leads me to my final point. Normalization is not the end-all be-all of relational design. Join dependencies and functional dependencies are not the only kinds of constraints, but they are the only kinds of constraints normalization helps us with. For any other kinds of constraints, think about things like default constraints or check constraints. Normalization provides zero guidance for these. Another thing to keep in mind is that there can be multiple non-loss decompositions into fifth normal form for a given relvar, but there is no solid guidance on which to choose. All of them can be valid for 5NF, but some might make more business sense than others. Third, applying academic advice to practical circumstances is not always a direct mapping. Academicians get to sit in their ivory towers and dream things up. Meanwhile, people in the field are stuck with real-world scenarios, real-world problems, and real-world people who can't give you a list of functional dependencies at will. Finally, keep in mind that normalization is explicitly about the logical model, not the physical model. Your physical model will absolutely differ from your logical model, as it can include additional constraints, indexes, stored procedures, functions, and even different table design than your logical model's relvars. So that's going to do it. If you've made it this far, congratulations. Assuming you pass the final exam, your certificate of passing this course will be in the mail. Now get out of here. Class dismissed. I hope you enjoyed this series on normalization. I know how deep into formal logic normalization can get, and that can be a problem for practitioners who aren't used to thinking in this way. But hopefully, I've given you some things to think about and clarified the topic a bit. I'd love to know what you think in the comments below. We'll have links and show notes in the description below. And until we see each other in the next video, take care.